Now that we have a decent understanding of functions, we're going to start to use them in different operations and something called a composite function. So those operations are addition, subtraction, multiplication, and division, and then we have this composition of functions. When you're adding functions, you might see this notation that says f plus g of x. All that says is it can be written as f of x plus g of x. So if it said like f plus g of 2, you could evaluate f of 2, evaluate g of 2, and then add those two things together. Same idea with subtraction. F minus g of x is the same thing as f of x minus g of x. So f minus g of 2 is the same thing as f of 2 minus g of 2. If we're doing multiplication, you might see f times g of x, which is the same as f of x times g of x. And with division, f over g of x is the same as f of x over g of x. Now when we get to this composition of functions, this is like having one function inside of another. So the way we're going to do these is we're going to go from the inside outward. Whatever's on the inside, we're going to evaluate that first. Then that's our new x term in the outside function. So wherever we see x in this outside function, that's what we're going to put what is on the inside of these parentheses. This might sound weird at first, so let's just look at some examples. We're going to use these functions to answer some questions. F of x is equal to 2x plus 6, g of x is equal to x minus 1, and h of x is equal to 5x. So first we've got f plus g of x. I'm going to start by rewriting that as f of x plus g of x. That's a lot easier for me to substitute because I can say, oh, I know what f of x is. F of x is 2x plus 6. I know what g of x is. That's x minus 1. So I can substitute those in for f of x and g of x, and then combine any like terms that I have. So again, substituting that in, now we have 2x plus 6 plus x minus 1. This was our f of x, this was our g of x, and we can combine like terms to simplify. So 2x plus x leaves us with 3x, and 6 minus 1 leaves us with 5. We don't have a value of x, so there's nothing to evaluate here. We're just simplifying, so we're done. Number 2, we have f minus g of 3. Again, I'm going to separate that out into f of 3 minus g of 3. So what that means is in my f function, I'm going to put 3 in for x. In my g function, I'm going to put 3 in for x. So let's start by doing that. We've got 2 times 3 plus 6, that's from the f function, minus, and then evaluating 3 in for x, 3 minus 1. I'm putting this in parentheses because I want to make sure I subtract this entire term, not just the 3. So simplifying further, we have 2 times 3 is 6, plus 6, minus, and 3 minus 1 is 2. Then 6 plus 6 is 12, minus 2 is 10. This one comes out to be an actual number because we were able to plug something in for those x values. Number 3, we have h times g of x, which is the same thing as h of x times g of x. So my h of x was 5x, so I'm going to put that first, times, and then I'm going to put it in parentheses, x minus 1. You don't need to put this dot here, you can just put 5x parentheses x minus 1. So since we're multiplying here, we have a monomial, just one term that we're multiplying into that binomial, so we're going to distribute to both pieces. 5x times x is 5x squared, and then 5x times negative 1 is negative 5x. We don't have any values of x to evaluate, so we are done. Number 4, we've got g over f of 1. Again, that is the same thing as g of 1 over f of 1. So if we were to plug 1 in for g, that would be 1 minus 1 over, and if we plug 1 in for f, 2 times 1 plus 6. Well, 1 minus 1 is 0 over, 2 times 1 is 2 plus 6 is 8, but 0 divided by any number is just 0, and there's our answer. Now here's this composition, this new thing that we're looking at. this is written as g with this tiny little circle and then f, which means g is composed of f of x. So the way this can be rewritten, this letter on the left is our outside letter. Inside of g, we're gonna put f of x. So what that means is we've got this function g. It is originally g of x. But now instead of x being here, this is f of x. So what that means is wherever I see x, I'm going to put f of x. So right now I have f of x minus 1 because it started off as x minus 1, but now I'm putting f of x instead of x. Then, since I know what f of x is, that's the 2x plus 6, I'm now going to plug that in for f of x. So we've got 2x plus 6, and then that minus 1 that we already had from the g of x. Now there's nothing else we can plug in, so we can go ahead and combine like terms and simplify. The 2x has nothing to combine, so we still have 2x, and then plus 6 and minus 1 leaves us with plus 5, and that is our final answer. So again, if you have a composition, this first letter is your outside function, the second letter is what's going inside of it. So here I put f of x inside of g, which means anywhere I see x in this g function, that's where I put f of x. So I have f of x minus 1. Then I knew that f of x was 2x plus 6, so I plugged that in for f of x and simplified.